Hello, we are Albina Zavgorodniaia,
Juho Leinonen,
Shrestha,
and John Edwards.
We are going to talk about circadian rhythms and how they manifest themselves in such data as keystroke timestamps of the programming assignments which were collected in two universities in the US and in Europe. Circadian rhythm is a cycle of internal oscillations in nearly all physiological body processes or activities. Its period is approximately 24 hours. During those hours, the activities reach their peaks and lowest points. One can think, for instance, of a state of highest alertness as a peak and irresistible drowsiness or sleep as the lowest point. It has been shown that academic achievements and task performance are influenced by circadian rhythms. A chronotype is a person's natural inclination towards activity at certain periods of the day, and it depends on circadian rhythm. Chronotype can be treated as a personal characteristic, which, however, is not fixed and changes during the lifetime. People have to distribute their tasks and activities across the day according to various schedules, taking into consideration social constraints. It is called clock time preferences. The clock time preferences are more likely to match a chronotype conditioned by a circadian rhythm when an individual has more flexibility in activity organization, most often during weekends. Many of us heard about morning larks and night owls, but today 4 chronotypes are known: the morning type, the napper, the afternoon type, and the evening type.
In this study, we decided to look whether we can observe these 4 chronotypes in programming process data. Our first research question is, what chronotypes would be discovered from clustering keystroke data collected from 2 contexts? We have data from 2 contexts that we call US and European. In both, we collected keystroke level data from students completing programming assignments in introductory programming courses. The keystroke data includes timestamps that tell us when students were working on assignments. We clustered students based on the time of day of the timestamps in the data. The specifics of the clustering approach are in the paper, and in the interest of time, I won't go over those now. With the clustering approach, we found 4 clusters. Here, you can see the distributions of keystrokes for the 4 clusters in both contexts. The first observation is that these clusters are very similar to the 4 chronotypes proposed in earlier work, where they were called the morning, napper, afternoon, and evening chronotypes. Because of this, we decided to call the clusters we found with the same labels. Another observation is that the clusters are very alike in both contexts. The contexts had some differences. For example, in the US context, there were 10 large projects in the course, whereas the European context used a many small assignments approach and had 147 assignments in total. The fact that the 4 clusters match between these contexts provides additional support for prior findings on the existence of 4 different chronotypes.
Our second research question is, how do the typical working times of students relate to academic outcomes? Of the 4 chronotypes that were discovered, we find that students who worked in the morning and early afternoon tended to perform better in a variety of outcomes. We consider 4 outcomes: project scores, exam scores, how long before the deadline students worked on the projects, and the number of keystrokes required to complete the projects. We first look at correlations of chronotype with project and exam scores. We see a pronounced difference in median project score between the 4 chronotypes in the US context, but much less so in the European context. And indeed, there are strong significant differences in the US context and no statistically detectable differences in the European context. We see similar phenomena relating to exam scores for the US context strongly significant differences exist, whereas the European context showed almost no difference, although the European context may have been influenced by the ceiling effect in this case. For both project and exam scores in the US context, morning and nap students perform better than afternoon and evening students. We also considered the correlation between chronotype and how far from the due date students worked on the assignments. Both the US and European students showed strongly significant differences, with students who worked on the assignments in the morning generally starting and finishing earlier relative to the due date than students who worked in the evening and nighttime. Similarly, this figure shows the number of keystrokes executed by students. Students in the evening chronotypes type fewer characters on average than students in the other chronotypes.
Our third research question is, how do contextual factors affect academic outcomes? One of the most notable differences between the US and the European contexts is the time before the due date of the keystrokes. We see that in every chronotype, students in the European context worked on their projects at least 25 hours earlier, on average, than students in the US context, and European morning students worked fully 50 hours earlier on average. We propose two contextual differences contributing to this effect. The first is the late work policy. In the US context, students could turn in late work for reduced points. In the European context, late work was not accepted. The second factor is project composition. In the US context, the projects are broken into two sub-projects, while the European context has tens of sub-projects due each week. Related work has shown that when projects are broken into smaller, multiple pieces, students tend to start earlier. Considering the factors of late work policy and multiple smaller projects, it isn't surprising that students in the European context start earlier than students in the US context. Our data shows afternoon and evening students performing, in general, at a lower level. We consider the possibility that the university class schedule forced these students to work at suboptimal times, contributing to their subpar behavior. To see if the imposed schedule affected their natural working time, we compare each chronotype's keystroke distributions split between weekdays and weekends. This figure shows the weekday-weekend distributions for the evening chronotype in the US context. We would expect students to be more free to work according to their preferred schedule on weekends. As can be seen in the figure, students behaved very similarly on the weekends as they did during the week. It appears that synchrony had only minimal effect on afternoon and evening student underachievement.
Our results are in line with the previous research, pointing at the link between chronotypes and academic outcomes. As computer education researchers and practitioners, we should consider this for our future course development and give a better opportunity for students to perform at their optimal hours. When conditioned by individual circadian rhythms, students are more alert and potentially most productive and efficient. There are limitations of this study. We did not collect demographic information and thus do not know which of the students might have jobs or other classes. It may have affected our chronotype distribution. However, the effect of these external factors seems to be minimal. For details, please see our paper. Furthermore, Putilov et al., who presented the new chronotypes classification, has also discovered a group of people that does not belong to any of the clusters. For the future studies, we are looking forward to examining the interplay of task difficulty, chronotype, observed behavior, and performance within the domain of learning programming. We thank you for your attention.
Hello again. Here we are in the QA of our last paper of this session. Albina and John are here with us to answer your questions or elaborate about your comments. So please feel free to write any comment or any issue in the chat. It will be very welcome. So in the meanwhile, I will start with a couple of questions. So the first one is if you have information about the reason that takes the students to work in some specific time frame. For example, they have lectures in the morning and they can only work in the evenings in their assignments, or the other way around. So do you have this information?
Well, actually, we did not gather this information from students, and indeed, there are many obligations which we don't know about, and students tend to choose their time according to their own dispositions. However, because of that, we checked also the time when they worked during weekends and weekdays. Okay. So John can tell you a bit more about it.
Yeah, so the we split the students, right? Or for each student, we looked at their behavior during the week and then during the weekend, and found that yes, they do behave differently during the weekend, but it's very, very similar. The effect size was like 0.2. So the takeaway from that is that yes, they are constrained by their classes and their jobs and their other obligations as to when they work on their programming assignments, but the effect is very low, and they tend to gravitate toward working at the same times, regardless of what their obligations might be.
And there is some research which actually talks about that during weekends people tend to compensate time they spend during weekdays. So for instance, if they're not the morning time, they tend to sleep more during weekends and during weekends. So there is information about that, tend to come back to their normal chronotypes during weekends, so that we can actually believe our results that they differ not that much from weekdays, and so the students behave more or less according to their chronotypes.
Okay. So in the chat we have a comment by Paul. He says that it's a very interesting study. Thanks, Paul, for the comment. And then we have a question by Maria. She said that it's a very interesting study. Thank you. You mentioned that splitting into smaller tasks made the students start earlier. How a small task would be optimal? So, what do you think?
That is a fantastic question, and we wish we knew the answer. Maybe Abby has more, but we didn't look at that. But we can tell you roughly what the assignments were in our study. So the larger tasks were week-long programming assignments, and you see all the results of those. They tended to start later. The smaller tasks, I'm trying to remember. Do you remember, Abby, how big those were? I think there were
no,
like
not really.
Per week or something.
Yes. They were quite, could tell that they were sort of subtasks, not very long, like a little exercises, more or less.
Yeah.
So it doesn't look that scary if they know they can accomplish one task in a roughly short period of time, rather than they know that there is a big thing coming up, and so they procrastinate maybe a bit more.
Okay. Thank you. So we have another question by Elke, a follow-up to my question. The study programs were full-time study programs in general, so that you can infer that classes are during the daytime, or there were also evening classes involved?
So in
Finland, I don't think so. Oh, sorry, John.
Go ahead, Abby.
It was during the day. I don't recall there were evening classes, but students could choose their time. Oh, yes. It's rather, the lectures happen in the prescribed time, obviously, but there is a choice when which course you choose and what time it is. So students could decide beforehand according to understand they want to spread their load. So it was more or less free, but but the lectures were at the same time during the day. What about you?
Yeah, the U.S. context, the course that we of study that we were studying were all during the day. All the lectures were during the day. However, as pointed out by Elke, this is a full-time program for many students, so they're taking other courses besides ours, and so we don't know whether they were daytime or evenings courses. So that's certainly a hidden variable that we simply didn't collect data on.
Okay. I had another question. Which would be your recommendation or your advice if you had, let's say, a son or a daughter that start the program? What would you advise according to the experience or the knowledge that you have gathered in this work?
I can try. I don't have children. I will recommend one day. So there is, from the previous research, that students tend to work better in their optimal times. So if they know their chronotype, it's not difficult. Well, just pay attention to how you feel during the day, and you'll figure it out. So you'll notice when you're most alert during the day, and so the most difficult and the demanding tasks I would recommend to schedule around that time, because you're most productive at that moment. And it's a good thing, especially if you have this in mind, what your chronotype is. For instance, during 2 p.m. every day, I feel very sleepy, so I don't plan anything that's demanding, maybe meetings, because it's easier to contact, and it actually helps. And so during studies, just shuffle the tasks so that your abilities.
And as Abby said, that's the most important thing. However, we did find correlations with chronotype and performance in some cases. For example, morning and afternoon students tended to start earlier on their assignments, had improved outcomes by some measures, whereas evening and night students, or napper and evening students, didn't perform quite as well. Now, right, this is correlation. We don't know what the causation is. And so the most important thing that we do know is, as Abby said, pay attention to how you're feeling and schedule your activities around that. However, there is something to be said about working in the mornings and afternoons.
Yeah, it also might be due that those people whose chronotype doesn't correspond to their daily life, it works during the day, and lectures also start during the morning. At those times, people who are evening or napper types are not in the they have to, because they are obliged, for instance, to visit the morning lecture, and so they are not in their best condition for that. So literature on that, it assumes that because of those dysynchrony, students perform worse. Probably if they could attend evening lectures and do everything, the most demanding, as I said, in the evening, it would be better. But we're living in such a world where there is not enough flexibility.
Yeah. Okay, good. Thank you very much. Just on time. Thanks, everybody.
Thank you.